It's always DNS, unless it's not. And I think we're all familiar with this problem and why it's important for us in monitoring. But before we get into that, let me take care of some formalities about me and my employer. I work for comNET. We're an IT systems house based mostly in Hanover. We've been around about as long as I've been, and we've been a Checkmk partner since 2014. We're also a gold partner. My background's in psychology and IT. I did a bunch of software development, and as of recently, I'm an IT consultant for open source software, specifically Checkmk. And I don't know, if you have no questions about the talk later on, I'm also a dungeon master for D&D and Pathfinder and the like, and you can come by. We can chat about that as well. Nice. All right, but since we're here in beautiful Munich, let's talk a bit about the worst case in DNS. Large-scale failure. Now, you can already see where this is going. Many of you probably are familiar with this case. It's the year 2021, and the WhatsApp group of the family is suspiciously quiet. You've gotten no pictures of anyone's lunch, dinner, whatever, and just overall, Insta doesn't seem to be reachable. Clearly, something is going wrong at a large scale for Facebook Meta as a whole. What's going on? Facebook is experiencing massive outage, and it's ultimately a silly and painful mistake where a couple of things compounded to make things go wrong. A routine maintenance command was set off. There was an error in it, according to the infrastructure team, and there was a compounding error in an auditing software that should have stopped it going out, and effectively, they shut down the entire backbone. And then BGP prefixes were withdrawn, routing stopped working to their DNS, and at the time, Facebook hosted the entire DNS system themselves. As a result, DNS access for Facebook was completely severed, and the impact went beyond what we, as maybe users of Facebook's products, saw, and actually affected their recovery as well in quite some depth. So let's talk about the impact a little bit. Number one, and I think this is kind of the most interesting one because it's a bit of an artifact of the time and it's a tricky one to get by, was access badges. Physical access to data centers was limited or completely constrained. Apparently teams turned up at data centers to try and do a hard reset. They couldn't get inside because their badges weren't working. Then keep in mind, it's 2021, people are in home office a lot, there's not a lot of people on site, you're trying to communicate, you have a crisis, email isn't working. So you have to go over to other services. I mean, WhatsApp isn't working, right? That's probably also something you might be communicating on. And so you're, under a lot of pressure there. Beyond that, the tooling that would have been used to recover a lot of this wasn't working. And ultimately, let's face it, it's a business. There was a cost to all of this. Facebook shares took a dive. They lost a lot of revenue. I'm not a business analyst. You'll have to ask someone else about the details. You can see now, long term, they seem to have done fine. But at the time, I think Mark Zuckerberg's net worth went down to 120 billion or something. Very tragic. I brought a couple of screen captures here. This is not a Facebook data center. This is from a German series, Feuer und Flamme. They go with fire department teams on various missions. And here you can see them trying to break into a data center. They're going through the safety doors. And I love this one particularly. They got through the first door. In the background, you see the next door. I don't know how they got into their data centers in the end, but this is kind of the image that comes to mind in the worst case. So let's talk about the struggles with DNS and monitoring DNS. It depends a lot on how big the environment is and what kind of tooling you're using that's currently encountering a problem. But until you actually know that it's DNS or something else is causing it, the symptoms might be very similar, and it could be just a multitude of different issues that are behind the scenes causing your problem. And it may not always be obvious that it's DNS, and you may be chasing down the wrong lead for a while. And as a result, it's very important that we do monitoring well for this kind of system. Let me tell you the story that actually got us onto this topic briefly. It's a customer story of ours. We work with a large insurer in northern Germany, and they had some very strange issues with an SQL check that was showing a very consistent latency. And it was approximately 15 seconds, and it was very frustrating to diagnose because Checkmk was otherwise showing up fine. We otherwise didn't really have resolution problems in the network. And as such, because only this one particular thing was failing, and a lot of other stuff seemed to have been going via different resolver or different or via IPs, there was a lot of time spent trying to figure this out, since it looked fine overall. What ultimately caused it was, as you can probably guess, it was DNS. And the cause was, I think it's quite common in a lot of big environments, DNS was being configured dynamically, and so something had changed in the configuration. And some DNS servers were fine, they were resolving, but in this one part of the network, this particular DNS server was not resolving addresses. And as a result, it was timing out in that zone, and it was working fine elsewhere. You were able to resolve stuff, but this check was struggling to get its location. And this was very annoying to debug. So this is a more complicated issue. I think I've been approached by several people yesterday. I've talked with a lot of colleagues about this topic recently. The most common issue is obviously quite simple to solve. There's an issue with connectivity. A customer reports something, maybe device is unreachable. We do some diagnostics. We find out it's reachable via IP, or maybe we did an NS lookup and found that there's a DNS problem, and we can figure this out quickly. And as a result, I think because this is the classic, a lot of the stuff is built around this usual case. But in cases where we have this more dynamic problem, it can be a little more difficult. Let's have a quick look at what Checkmk already does. Because a DNS failure can happen to anyone, and we're monitoring, and it's not really supposed to happen to us. We're supposed to be able to see this kind of thing. We want to have eyes on the network, and such a crucial service is something that we want to really be able to monitor properly. And Checkmk has some great functionality for most use cases. We can start with the built-in functionality to have just an active check going. You can run it on your site. You can see, is broadly DNS working on my site? And you can see here there's some different options for configuring how to choose which DNS. But there are some limitations in this that we ran into, and that's the transparency. It's not always exactly clear which resolver is currently being used and maybe where it's going wrong. And as a result, it's not necessarily useful for very dynamic configuration. The other option, it's also interesting for monitoring different sections of the network, is the agent plugin. You can deploy with an agent. You can have it monitor in various zones, trying to resolve addresses. And this is great again, but once again, we have a bit of a transparency problem, and we don't want a ton of agents constantly polling DNS, since this will also affect our performance of DNS. So we saw kind of a niche here, and we wanted to build something for our specific use cases for a few different customer environments. And as a result, we made a little plugin that we'd like to show you. The idea is that we have a special agent now that will look for all dynamically configured DNS resolvers that it can find in the etc resolve conf, and it will try those out. But beyond that, it'll also measure that latency, graph that nicely for us, and distinguish by the different target domains that we configure, but also, and most importantly, by the DNS resolver it used to resolve that. So if you have a new configuration, your discovery service will say, hey, something's changed, I found new services, maybe you want to have a look at this. And ideally, if a faulty configuration was rolled out, you'll know immediately, because you'll see, oh, OK, this is not working as it should be. What does this mean for you? Well, the good news is we've made it available already. It's already on GitHub. I'll throw up a link in a second. It's also on Checkmk Exchange. You can find it on, I think, a multiple local DNS resolver. So I already had a couple of downloads, I guess, since it's at the top of the list right now. The bad news is, obviously, we've built it for a specific use case. This may not exactly cover your use case at this time. We went for the special agent. We went for monitoring from the site. I can absolutely imagine someone saying, OK, we want this in the agent or the like. But the good news is the whole idea behind this is we wanted to make it public. We're absolutely open for pull requests. And obviously, if anyone wants to reach out, maybe sponsor some feature that they specifically want, or maybe want to just give some input for improvement, you're absolutely welcome to do that. All right. Leaves for me to throw up the QR code. Probably a little short now to try and grab it, but look for multi-DNS on GitHub, on our comNET GitHub site. And like I said, it's also on the Checkmk exchange, so you should be able to find it there. If you have any questions after the question round now, we still have some time, feel free. We also have a stand at the back with the physical appliance. It's right by the ice cream, so you're probably going by there anyway. Stop by and say hi. All right, thank you very much.